Hey, this is Kenneth, and more progress has been made on the Z80 breadboard computer. So, in the core of it, we've got a Z80 microprocessor. I've built this kind of display front panel, which again, we've got the address bus, the data bus, the M1 signal, read, write, I/O, and memory. So these are your 5 control signals. I've got the refresh line here, which is essentially just dim. But the big change since my last video is that I've added 32K of SRAM. I've added a 27C256 EEPROM that has the Microsoft Basic binary on it. And I've installed a 68B50 UART. So essentially, here I have built a RC2014 Micro. I have just exploded it out in breadboard form. The major difference, other than the fact there's a bunch of LEDs, is that normally the RC2014 Micro runs at 7.3 megahertz, and so the UART divides that by 64, and you get a 115.2 baud on your serial port. So what I've done instead is I've set up a 555 timer to run at 19.2 kilohertz, which gets divided down to 300 baud, and the Z80 then runs at 19 kilohertz. So I'm running essentially an RC2014 Micro running Microsoft Basic, but just really slow. Well, not really slow, just mostly slow. And so right now we can see that we are executing a lot of instructions that are reading from memory, and we're staying mostly in the lower part of the ROM and some memory access, because the memory is the top half. So when this light is lit, we're accessing RAM, and when it's not lit, we're accessing ROM. So that's what we got. In addition to that, next to the UART, I've got hardware flow control running, and so this red LED here is the RTS signal to the computer to say, so when RTS is negative, this light is lit to say, hang on, I'm not ready to send. And this yellow LED here is the interrupt line from the 68B50 back to the processor. And so right now we're just at the basic prompt, and it's just essentially doing a busy loop. And so if I start typing, every time that I press a key, you can see the interrupt lights, because the UART receives a letter, and then you can see the interrupt routine in BASIC run a little bit, which transfers the single character it got from here into a buffer until you press enter, when it then processes it. And so now let's do a full reset, and so we can see what the reset looks like. So hold down the reset button, and you can see it was doing a little bit of writing to I/O, and that was it printing the Z80 SBC by Grant Surley, cold or warm start. Now I'm going to do a cold start, and then it's going to ask for the memory top. Normally you just hit enter and let it figure it out on its own, where it scans through your whole address space. That takes a really long time though, so I'm instead going to type 65,000, which you can see every time that I press one of those characters, which tells it that, the top of memory, the top of RAM is at 65,000 bytes, and so it doesn't have to then do the scan. So it does some processing. This is it printing out the copyright notice, and now we're back at the prompt. The cool thing about the RTS flow control and having the interrupt light is now if I paste a long program into the terminal, you will be able to see the UART post interrupts for each character as it receives them. The Z80 grab them until it fills the incoming UART buffer, and it then deasserts the RTS line to prevent the computer from sending more characters until it's ready, and then it starts processing the lines one at a time and printing them. And so if I paste, you can see here's the interrupt light blinking until the buffer filled, and the RTS signal deasserted. And now it's processing each line, and you can see it as it processes a few lines, it will assert the RTS, which turns the slide off, and you will see this blink a lot of times until it fills, then it goes back to here. And then for each line, you can see it thinks about it, and then it prints the line, which you can see by the fact that the I/O signal here gets asserted. And then once it's finished the line, it goes back to thinking about the next line, right? Because when you hit return, it then has to do all the processing in BASIC as far as parsing the line, checking for syntax, tokenizing all of your variables. And so if we go look at the actual terminal here, you can see it prints a line and then it thinks about it, and then it prints the next line, and then it thinks about it. And that's how fast this computer right now can ingest BASIC. So that's it running BASIC at this point. It's a little bit too fast to really directly follow what's going on, but it sure is a satisfying amount of blinky. So thanks for watching. More updates to come.